This problem involves evaluating 4 Java expressions. So we have to understand what the various operators do, and we have to understand the order in which the operators are applied. I've made a separate file for each of these different expressions so that we can look at them step by step to see how Java evaluates them. It matters the order in which we evaluate these operators. For example, if we were to compute 32 minus 3 first, then we're going to get a different answer than if we computed 3 times 4. So it matters what rules we use to figure out the order. When Java looks at this expression, it sees a minus, a times, a minus, and a divide. And between those 4 operators, the times and the divide have the highest level of precedence, so they're going to be evaluated first. They have the same level of precedence, and so between the two, they're going to be evaluated left to right. So we first compute that 3 times 4 is 12, and that leads us to this sub-expression. Then between these 3 operators, Java notices that divide has the highest level of precedence, so it's going to compute 19 divided by 2. Those are both integer values, and so Java is going to do integer division. Normally we think of the answer here as being 9.5, but in integer division we always end up with an integer as an answer. So 19 divided by 2 goes evenly 9 times, and the leftover is simply truncated or thrown away. So that leads us to this sub-expression. Now we have 2 minus operators, and they have the same level of precedence, so we're going to evaluate them left to right. This is a case where it matters that we're evaluating left to right. For example, if we computed 12 minus 9 first, we'd get a different answer than we're going to get. But Java uses the left to right rule, so we do 32 minus 12 first, we get an answer of 20. Now we have just a single operator left to evaluate, and we can see that 20 minus 9 is 11. So that's our overall answer. We can double check our answer by making a copy of the original expression and pasting it into the interactions window in JGrasp, and we see that Java also says the answer is 11, which is very good. We match. So we can move on to the second expression that has a whole lot going on. And we see a whole lot of different operators here, but we also see a set of parentheses. Parentheses are used to override precedence. So even though this plus operator wouldn't normally have a very high level of precedence, because it's parenthesized, we're going to evaluate it first. So we first compute that 72 plus 6 is 78 and come up with this sub-expression. Then Java sees a whole lot of operators here. There's a single minus in the middle here, and all of the other operators are multiplicative operators. There's a mod, divide, times, divide, mod. So all of those multiplicative operators are going to be evaluated before the minus, and all of those multiplicative operators have the same level of precedence, so they're going to be evaluated left to right. So we first compute 78 mod 10. Mod gives you the other part of integer division. So if we were to ask what you get by taking 78 divided by 10, in integer division we'd say that 78 divided by 10 goes evenly 7 times. Mod gives you the other part of this, the remainder, the leftover. So 10 goes evenly 7 times into 78, and what's left over is 8. So that's what mod gives us. So that's our next sub-expression. And then again, going left to right, we're going to next compute what 8 divided by 3 is. It's integer division again, so we get an answer of 2. And so that leads us to this sub-expression. Now, it sort of looks like this is 5 times 7/4 with the spacing here. But Java doesn't pay attention to spacing. Java has very simple rules that it applies very consistently. From Java's point of view, it sees times, divide, mod. Those are 3 multiplicative operators that have the same level of precedence, so they're evaluated left to right. So it's first going to compute that 5 times 7 is 35 and give us this sub-expression. Then it's going to take 35 divided by 4. That goes evenly 8 times with some leftover, but it was integer division, so we truncate that leftover. And then we're left with 8 mod 10. That's the next thing to compute. Some people are a little confused by this because they say, how can you divide 8 by 10? Well, 8 divided by 10 gives you an answer of 0, and the leftover then is 8 itself. So we're left with just a single subtraction operator. 2 minus 8 is a minus 6, and that's our overall answer. We can double check our answer by copying and pasting into the interactions pane, and Java comes up with the answer of -6 as well. So we can move on to the third expression. This one involves combinations of int and double. So there's some double constants here. Java looks at this and sees a single plus operator and a whole bunch of divide operators. So it's going to evaluate all the divide operators from left to right. So it's first going to compute what 38 divided by 4 is. Now Java doesn't care that there's a double coming up later on. What it sees right here is an integer divided by an integer. So it's going to do integer division here. So 38 divided by 4 goes evenly 9 times, and we truncate the rest. So we get this sub-expression. Now we compute 9 divided by 2.0. And we have a combination here of an int and a double. And when that happens, Java converts the int into a double. So this is going to be done in the domain of double. It's going to be as if it were 9.0 divided by 2.0. And the answer for that is 4.5. And that gives us this sub-expression. And it does the final divide here, which is again a double int combination. So it's as if it's dividing 19.0 by 2.0. So the answer we get here is a 9.5. Now, we could say with this final addition operation here that the answer is a 14. It coincides with that integer 14, but it would be more precise to say that the answer is 14.0. What we'd be noting here is that it's stored in the double format. So it happens to coincide with the integer 14, but it is a value that would be of type double. And that matters in terms of how you combine that with other values in Java. We can double check our answer with the interactions pane again, and Java also reports the answer here as 14.0. So moving on to the fourth expression, we have a combination here of ints and a string literal. So Java looks at this and sees a bunch of plus operators and a times operator. And the times operator has the highest level of precedence, so that's going to be performed first. So the first thing Java computes is that 2 times 2 is 4. That gives us this sub-expression. Now Java doesn't really care that we have a combination here of ints with a string literal. It just sees a bunch of plus operators, so it evaluates them left to right. So the first one it evaluates is 2 plus 2. And even though there's a string literal later on, what it's computing here is the sum of 2 integers. So 2 plus 2 is computed to be 4. So that's the next sub-expression. Then when we do the next plus operation, the string literal is involved. So we have an int plus a string literal. And when Java sees that combination, it converts the int into a string, and it does string concatenation. So this is turned into the string 42. It evaluates to the string 42. That's our next sub-expression. The next plus operation again involves a string literal with an int, and so it converts this int into its string equivalent and does concatenation. So we get 422. And now we're left with just a single plus operator to perform. Again, it's a string literal int combination, so it converts the int into its string equivalent, and we concatenate 4224. We can double check our answer here in the interactions pane, and we see that the answer here is 4224. JGraphs doesn't put quotes around it, but it's the same answer. So we can see here our various expressions and the answers that we got.